Carbonyl compound. First, we are going to look at the nomenclature of carbonyl compound. The general formula for carbonyl is CnH2nO. This is the general formula for aliphatic aldehyde or ketone. Both have carbonyl group. Two types of carbonyl compounds are aldehyde and ketone. These two are called carbonyl compounds because they have the same functional group, C double bond O. This is the carbonyl group. For aldehyde, the carbon that has double bond O has one hydrogen. But for ketone, the carbon that has double bond O has no hydrogen attached to it. That is the difference between aldehyde and ketone. Naming aldehyde. Aldehyde, the carbon double bond O that has one hydrogen. The parent chain must contain CHO group, and the CHO carbon is numbered as carbon 1. This is the CHO carbon, the carbon that has double bond O and it has one hydrogen atom, will be numbered at carbon 1. But omit this number from the name, means you don't need to write 1 on the name in aldehyde to state that this is carbon number 1. Don't write 1 carbon. Nomenclature of aliphatic aldehyde. This aldehyde, C double bond O, has hydrogen. This aldehyde contains 1 carbon only, so the IUPAC name is methanol. The common name for methanol is formaldehyde. Next, 2 carbons in aldehyde, it is ethanol. Ethanol common name is acetaldehyde. So this, the carbon that has double bond O is carbon 1, but don't put number 1. It's not 1 ethanol. That's what it means by omit this number from the name. Don't put number 1 in the naming. It's just ethanol. Here, 5 carbon in total, so the parent name is pentanol. Okay, you don't need to put 1. We know that this is 1. The carbon double bond O is 1. You don't need to put 1 pentanol. The parent name is pentanol, and at carbon 2 and carbon 4, 2 substituent, carbon 2 ethyl, carbon 4 methyl. So the IUPAC name for this compound is 2-ethyl 4-methyl pentanol. Cyclic aldehyde. When the CHO group is attached to a cyclic ring, suffix carbaldehyde is used. CHO has higher priority than other functional groups except for carboxylic acid and its derivatives. So the CHO, the aldehyde, is the second highest priority. The first one is carboxylic acid. The second highest priority is aldehyde. So here, the CHO group that is attached to the cyclic ring, we name it as carbaldehyde. Cyclohexane carbaldehyde. Cyclohexane because 6 carbon in the cyclic ring. And then carbaldehyde, showing that this is aldehyde cyclic. Next example, the aldehyde and then methyl group. So this is carbon 1, making this methyl as carbon 2. So it is 2-methyl cyclohexane carbaldehyde. In cyclic ring aldehyde, the carbon 1 is the carbon is in the cyclic ring. This carbon, not this carbon. This is not carbon number 1. Carbon number 1 is this carbon in cyclic aldehyde, making this carbon carbon 2. Next example, benzene ring with aldehyde. This is benzene carbaldehyde. The common name is benzaldehyde. Okay, this is the benzene carbaldehyde. The common name benzaldehyde. Next, in one compound, 2 different functional groups. Refer to the priority table. Priority table shows that the aldehyde has higher priority than alcohol, making aldehyde as the parent. So this is the parent. You have to find the longest chain. This will be carbon number 1. Carbon that has double bond O will be carbon number 1. Total 4 carbon. The parent name is butanol. This is carbon 3, so the name of this compound is 3-hydroxybutanol. Naming ketone. The parent chain is the longest one that contains ketone group, and the numbering begins at the end nearer to C double bond O carbon. We know that carbon that has double bond O in ketone cannot be at the end of the compound. So this carbon double bond O in ketone cannot be carbon 1, but you have to give the lowest number to the carbon in ketone that has double bond O. That's what it means by at the end nearer to the C double bond O carbon, because this cannot be carbon 1 because this is ketone, it's in the middle. So you have to give the lowest number for this carbon. Ketone group has higher priority to other functional groups except carboxylic acid and aldehyde. Means after aldehyde it is ketone. So the first highest priority carboxylic acid, second aldehyde, and then ketone. For example, this compound has 3 carbons in total, C double bond O in the middle. So this is propanon, ketone with 3 carbon named propanon. The common name of propanon is acetone. Next example, 4 carbons in total, ketone, this is carbon number 2. Okay, you have to give the number of carbon from the right to make this carbon has lowest number, because if you come from the left, this carbon will get number 3. So we have to give the lowest number. So you have to come from the right, making this IUPAC name butanon, 4 carbon in total. Next example, 2-methyl cyclopentanone. Cyclic ring ketone give this carbon double bond O at carbon number 1, and this must be carbon number 2, lowest number to the substituent. Don't give this carbon number 2, making this carbon number 5 wrong. You have to make this carbon number 2 lowest number to the substituent, still applicable, that rule. And then 3-hexanon. Start counting from the left, ketone, give the lowest number to the carbon that has double bond O. This one is 1-phenylethanone. The parent is ketone here, 2 carbon in total compared to this benzene ring. Benzene ring becomes a substituent because this straight chain carbon has functional group ketone. So the position of the substituent, it is at carbon number 1. So the IUPAC name for this compound is 1-phenylethanone. The common name for this compound is acetophenone. Next, this is diphenylmethanone, 1 carbon only, methanone, and at this carbon 2 substituent, benzene ring substituent, we call it phenyl, so diphenylmethanone. This is 4-hexene 2-on, still ketone. You have 2 different functional groups, ketone and alkene. Ketone has higher priority than alkene, so ketone will be the parent. This will be carbon number 2. Okay, start counting from the right to give the lowest number to C double bond O, so that's why 2 on. And then at carbon number 4 here you have double bond, so 4-hexene 2 on. Next, 4-hydroxy-4-methyl-2-pentanone. This is a functional group carbonyl and alcohol, so ketone has higher priority than alcohol, making this ketone as the parent. So the parent name is pentanone, 2-pentanone, because this is carbon number 2, and it has substituent methyl at carbon number 4 and OH group at carbon number 4. The name of this compound is 4-hydroxy-4-methyl-2-pentanone. Next, aldehyde and ketone over here. Aldehyde has higher priority than ketone. This is aldehyde, this is ketone. So aldehyde has higher priority than ketone. So the parent for this compound is aldehyde, making this as carbon number 1, carbon 2, carbon 3. If the ketone becomes the substituent, the name will be oxo. Okay, ketone substituent, it is oxo. So the name of this compound is 3-oxopentanal. This compound is 2-cyclohexenone. Ketone and alkene. Ketone has higher priority than alkene, making ketone as the parent. So this is cyclohexenone. Hexene at carbon number 2, alkene. So that's why hexene, not hexane. This is alkene. Or you can also name it as cyclohex2-ene, 1 on. This is also accepted. So it's up to you whether you want to use 2-cyclohexenone or cyclohex2-ene, 1 on.